Hello and good morning to all of you. I hope all of you are doing well. So, in today's class, we will be discussing about data analytics. So, data analytics, as we all know, is the science of analyzing raw data and a process of deriving meaningful conclusions out of it. Now, these meaningful conclusions can be used in order to refine or improve business models. It can be used in order to elevate productivity, in order to enhance profitability, in order to efficiently identify, analyze, and contain the influence of the risk. It can be used in order to build up new business models. So these are these are the application areas of data analytics. So data analytics plays a very crucial role in model engineering or business model engineering. So alternatively, data analytics can also be thought of as a mechanism for examining data set in order to discover or reveal prominent trends of data that are there in the data set and draw conclusions about it so that can be used for making quality decisions. So this is also the way how data analytics can be perceived. Now, data analytics techniques and technologies are widely relied upon by commercial organizations in order to enable themselves to make quality decisions that are capable of enabling the business organization to increase their business prospect, to increase their profitability and productivity. In addition to that, data analytics is also used by researchers and scientists in order to verify or approve or disapprove scientific models, scientific theories, and scientific hypotheses. Now, since some time, there has been tremendous amount of effort being dedicated for evolution of applications that are capable of analyzing data and are capable of drawing meaningful conclusions out of it, right? But the fundamental objective always remains the same for data analytical techniques, which is to analyze the data and to draw certain meaningful inference out of it. Now, as we have already learned, data analytical techniques or data analytic techniques is used in order to reveal predominant trends that are there existing in the data and matrices that would otherwise be lost in massive volume of information. Now, this information can not only be used for optimizing business processes, but it can also be used for enhancing operational efficiencies of the organization or systems. Now, let us try to understand what big data analytics is. So, whenever we say big data, we refer to data that is too large or too complex for traditional system to handle. So, whenever we talk about big data analytics, we are talking about business processes that are capable of handling big data. So, with tremendous amount of increase in the data to be processed by the analytical toolkits, there comes in a need for conceptualizing and developing a analytical technique that is capable of efficiently inspecting, cleaning, transforming, modeling data as per the requirement of the objective. It's capable of drawing conclusions and it's capable of enabling someone in making this quality decision. So just see, these are the set of activities that are associated with big data analytics. Now, data mining, which is a part of big data analytics, is an analysis process that is capable of modeling and discovering knowledge that are existing in the data, which can be used for making predictive analytics or performing predictive analytics. Now, in statistical applications, right? In statistical applications, business analytics is divided into descriptive statistics, exploratory data analysis, and confirmatory data analysis. Now, exploratory data analysis is concerned with determining or discovering new trends that are there existing in the data, whereas confirmatory data analysis is used in order to confirm or to reject or falsify a stated hypothesis. Now, we all know what is predictive analytics. Predictive analytics basically capable of making prediction about an outcome. So predictions are made based on the result of the analysis of either structured or semi-structured or unstructured data. This implies that big data has greatly revolutionized the way how industries perform their operation. So here now the industries rely heavily on big data analytics in order to make quality decisions regarding the business model as well as the product they engineer, which implies that there is a need for an able, cost effective data analytic technique that is capable of analyzing big data. Now, let us try to understand what data analytics is in a detailed manner. So, data analytics predominantly refers to an assortment of application. Data analytics refers to a set of assortment or an assortment of applications, right from basic business intelligence to reporting, to online analytical processing, to various forms of complex analytical techniques. So, data analytics is a broad term that encompasses many diverse type of data analysis. Any type of information can be subjected to data analytics, expecting it to generate data insight and draw meaningful conclusions out of it so that it can be used for improving the business model and increasing the productivity of the organization. So that is what the data analytics is all about, or big data analytics is all about. Now let us try to understand the steps that are involved in data analysis. So there are basically 4 steps that are involved in data analysis. The first step is dedicated for identifying the data requirement or how the data is to be grouped. So it's very important for one to determine data requirement, because it is on the data what we do is we perform analysis which will yield certain results. So selection of appropriate data is very much mandatory. So first is to determine what are the data requirements and how the data is to be grouped. Now in the second step, once the data requirements are attained, what we tend to do is we tend to collect data pertaining to the data requirements. So collection of the data can be done either from primary source or it can be done from secondary source. So primary sources, for an example, primary sources can be environmental sources or personal sources. Secondary sources may be some literature, or maybe, for example, sensors, right? Okay, so just see, that is the second step that is involved in data analysis. So first step is identifying the data requirements and to know how to group it. The second step that is involved is collecting information about the data that's processed. Now, once the data is collected, what we need to do is we need to prepare the data based on the requirement of the analysis process. So that is the third step. So once the data is collected, the data must be organized so that it can be analyzed. So organization may take place on spreadsheet or any other form of software application. Once the data has been prepared for analysis, then what we need to do is we need to clean the data. Cleaning the data basically refers to eradicating all possible problems that may be associated with the data. Right? So, for an example, inconsistencies, incompleteness, and ambiguousness can be looked upon and can be eradicated from the data set. So once the data has been cleaned, that implies data has been prepared for data analysis. So these are the 4 steps that are involved in analysis. First one is First one is determining the data requirement. Second one is to collect data. Third one is to organize the data as per the requirement of the analysis phase. And fourth one is clean the data as per the before the onset of the analysis so that analysis can be assisted. Now let us try to identify various characteristics of big data analysis, right? First characteristics is big data analysis should be programmatic in nature. So there might be a need to write programs for data analysis by using code to manipulate it or to do any kind of exploration because of the scale of data. So this is very much important. So the first characteristics of big data analytics should be programmatic, right? So one should be capable of writing programs for performing data analysis so that a large volume of data can be worked with. The second characteristics of big data analytics is it should be data driven. It means here importance or emphasis should be given on data, right? And then the program has to work on data in order to derive certain meaningful information. So here, in case of big data analytics, in priority should be given on data because it is using the data the analysis process will be capable of delivering certain result. Now the third one is attribute usage. So for proper and accurate analysis of data, it can use lot of attributes. So attributes basically refers to the data points. So in the past, analysts dealt with hundreds of attributes or characteristics of data source. With big data, there are now thousands of attributes and millions of observations. So this is very much important. So in order to get about a near to accurate or an accurate prediction about the object of interest or the objective of interest, what we need to do is we need to have the data being represented by a possible number of attributes, a maximum possible number of attributes, so that greater the number of attributes, greater would be the precision of the result that is being generated. And it should be iterative in nature. So iterative basically means this particular process has to be repeated in order to refine the entire analytical process. So over a period of time, iteration would definitely lead to enhancement in the ability of the analytical techniques to deliver the result. So as whole data is broken down into samples and samples are then analyzed, data analytics can be iterative in nature. So more computation power. So in each iteration, more computation can be involved in order to satisfy the requirement of the business process, right? So this is very much important. So these are the characteristics of data analysis. So it has to be programmatic in nature. It has to be data driven. It has to use the set of attributes, and it has to be definitely iterated. Now let us try to identify some of the key takeaways. The first takeaway is that data analytics is a science used for analyzing raw data in order to draw certain meaningful conclusions. These meaningful conclusions can be used in order to improve or refine business models. It can be used in order to increase productivity. It can be used in order to elevate profitability. It can be used in order to efficiently manage risks. It can be used as a scientific basis for evolving new business models. Now, these techniques and processes, the techniques and the processes of data analytics, in certain situation can be automated to certain extent so that it is capable of efficiently delivering the results. So that's also important because it may be at times very difficult for us to run a very complex process. So if it is automated, then what we can do is we can perform the task of analysis with relative ease. So next important aspect is data analytics helps a business to optimize its performance, definitely. So with the help of big data analytics, what we can do is we can optimize our business process. We can not only optimize our business process, we can also improve our operational efficiency or optimize our operational efficiency. So why data analytics matters? So data analytics matters because it is important. It helps in optimizing business and their performance. It helps in elevating the quality of the results that are being generated. It helps in enhancing or in profitability and increasing elevating the quality of the product, right? So it can data analytics, if executed properly, can help in reducing cost. Okay, so this is one of the implications of data analytics. So if it's implemented properly, then what we can do is we can reduce the total amount of cost involved in not only building the model but for managing the business. So that is also very true. So here, using business data analytics or data analytics, what we can enable is we can enable better decisions, leading to increased productivity, right? Okay, and better products and services. So these are some of the advantages or notable advantages of data analytics. So in today's class, what we have learned about is we have learned about what is data analytics, what is big data analytics, and then we have learned in detail something about data analytics further, right? Then we have learned about steps that are involved in data analysis. We have learned about characteristics of big data analysis. We have learned that it has to be programmatic, it has to be data driven, it has to be attribute, it has to depend on usage of the attribute, and it has to be iterative in nature. And then we have identified some of the key takeaways and why does big data analytics really matter. So thank you very much. Have a very good day.